And on part of the hyperbola, I explained that when you have a straight line like this and you're moving to the right, from the left to the right, if you're moving from this side going that side, and as you move to the right, the line drops down, that means the gradient is negative. So equation of a straight line is sorry guys, mx plus c, and then we said m is the gradient, and I said to you, if when you move from the left to the right, the line drops down, it means the gradient is negative, so meaning you can have a negative gradient here, m. And you remember how to get m, also explained on part 2 of the hyperbola. And this side, for this side, p and q still the same, 0. But now in this case, for this one, for this graph, this was for that because a was positive. So for this one, a has to be negative. So we need a negative a for this part to exist. So still passing through point P and Q. P and Q are 0 because they become the light axis of symmetry becomes the asymptote, the ordinal asymptote. So this point here will become a point on the line. See that? But now look at this line here. As I move from the left moving to the right, the line goes up. You see that? I'm moving from the left going to the right, but the line is going up. It's going up. So because of that, m gonna be positive. So it's greater. Yes. So that's right like that. M is greater than 0. M is positive. So meaning the equation to this will be y is equals to mx plus c, right? That's it, guys. So you should know that the value of m for the axis of symmetry, sorry guys, the value of m for the equation of symmetry is equals to plus or minus 1, meaning this line goes at an angle of 45 degrees there. That is 45 degrees. You see? So, and if you say tan 45 on your calculator, you'll get that. But we will discuss that more. We will discuss that part of relating angles and the gradient and the degrees. So we will explain that on the next part. So when they say calculate the equation of symmetry for this hyperbola here, you need the equation y equals to mx plus c. Y equals to mx plus c. For this part, because it is decreasing, that line is decreasing, m is going to be negative 1. For this part, m is going to be positive 1 because the line is increasing. See, so this will be y equals to, oh, what have I done there? What have I done? Y equals to positive x plus c, because 1 multiplied by x just becomes x. So if you have this, then solve. And this side is going to be y equals to negative x plus c. There you go, guys. You see that? So from here, you only need to use the coordinate of p and q. You're gonna use the coordinate of p and q. That coordinate, you're gonna substitute it on this equation to find the value of c, so that you can find c. Given this side, you're gonna use the same coordinate there, and then you're gonna find the value of c. Once you have the value of c, you can write the straight line. So if they say write the equations of symmetry, this is the equations you use, this one and that one, and you will decide as to whether it is positive, the gradient is positive or negative, depending on how you draw the hyperbola, looking at a is greater than 0 or less than 0. There you go, guys. So when I explain the last part of the hyperbola, you will now understand. I just needed to make that clarity. Thank you, guys. All right, guys, that being said, let us go to the next one. The next one we have y is equals to it's 3 over x. We use a different color for this. X minus 1 plus it's plus 1. There you go. So here you can see E is equals to 1. Q equals to 1. Remember guys, when you're finding P, I said if it's negative here, it means it was positive on its own. The negative comes from the formula guys, the order. So if we are finding the asymptote, we say x minus 1 equals to 0. Therefore, x is positive 1. That is why I'm saying 1 there. And for Q, it's just straight because it was positive there or there. So positive 1. So meaning y is equals to 1. So this is going to be the horizontal asymptote, and that is going to be the vertical asymptote. The asymptote guys. Now you need P and Q. Why? Because we are going to use it to find the equation of symmetry. P and Q is 1 and 1. There you go. So let us plot, guys. Let us draw the graph and see how it goes. See that A is positive, it's positive 3 there. A is positive. So okay. So what we will do is draw the asymptote lines. So P is 1. 1. So we'll start by doing that. Remember, if it's negative here, the graph shifts to the right. Okay, then let's say 1 here. For that one, 1 is there. So then I'll take asymptote line. There you go. Side. There you go. It says positive x, y, x, y. So this point here, where the asymptotes meet, what is the coordinate there? Coordinate there is P and Q, because it is where the asymptotes meet. Where P and x and y, those ones, the asymptotes meet. So this coordinate is this coordinate here. So now we're gonna draw a graph. When x is 1, it's gonna be 1 minus 1, so it's gonna be 0. So it's gonna be 3 over 0. Understand that? So we will not have that point there. And when x is 2, it's gonna be 2 minus 1, 1. So it's 3 over 1. Okay, that is 3 plus 1. So 4. So there's a point there, and when x is 5, for example, 5 minus 1 is 4 over 4 plus 1. So the graph is going to be something like that, and then the graph something like this. You know, the graph does not touch this line. These lines are the asymptotes, not touch them. The graph would never touch these lines. Here the asymptotes together. So you have it like that. So now you have to draw the equation of symmetry. To write the equation of symmetry. So we can start by drawing that line. we can see we have a half first quadrant and third quadrant. So it means that line comes like this, there, okay, like that. Don't like that. I should have used a different color, guys. Please allow me to use a different color. Make line. Oh, okay, that equation of symmetry. We need the equation of this line. This is the line of symmetry, guys. This, if we reflect this graph, we will get that graph. If we reflect this graph about this line, we will get this one. So these half sides of this hyperbola, they are reflect them about this line. That is why the line of symmetry. So we need the equation of this now. So now with y is equals to, remember it's mx plus c. Y is equals to, what is the value of m? Going down. So what is the value of m? It's minus 1. Remember on the previous one I explained that there's going to be minus x plus c. Then you need a coordinate you're going to use. It passes through this point. Know this point. This one we do not know. This one we do not know. But we know this one because it is where the asymptotes. So that is P and Q, 1 and 1. Right? Therefore we'll say substitute this, substitute y and x as 1 plus minus 2, 1 plus c. Therefore c is equals to 2, because this minus 1 will go that side and become positive. So therefore the equation equals to y equals to minus x plus, this is the equation of symmetry. Of course you can test it. If you take this equation and you substitute the value of x for the asymptote, you get the other value, the value of y. If you substitute 1 here, minus 1 plus 2, that's positive 1. That one. So it's correct. This is the equation of symmetry. It's like this. And if the graph was using quadrant 2 and 4, and then maybe get the asymptote somewhere there, so it was going to be like that. So m was going to be positive. So it was going to be y equals to positive x plus c. And then the coordinate was still going to be coordinate here, p and q. Alright guys, I hope you understand that and ask questions. So we are used to a hyperbola coming with this standard form. Like that. So today we are going to move from this form to that form. So we'll be given information in this form and we'll have to write the equation in this form. So you are given this, you have to write it in that form. So you need to know how do you go about that. So when you are given this, you will be given a point on a graph, say for example this is 2 and 0, and you'll also be given the x coordinate of the asymptote. So the asymptote where the two asymptotes intercept is going to be the coordinate, let's say 1 and q. So it's 1 and q. So we know 1 represents p. So it's p and q, but the value of q we are given is 1. There, the value is 1. So I can even draw the graph. For the graph, show the asymptote. One, okay. This one we know value here is 1, but this one we do not know this value. Just know it's q. No q here, but we don't know what is the value of q. Y, this is x, okay. All right, like that. So let us draw graph. That. All right, there we go. So we're given this point C, P, 2 and 0. There we go. So we're given this information. So now here, the first thing you need to do, guys, is to take the coordinate that you are given and substitute it in here. Substitute y and x and then solve. So we are given coordinate 2 and 0 here. C, when C is 2 and 0, I will substitute it here. So let's go there. So y is 0. 0 is equals to x is 2. Is 2 minus a, but 2 minus p. So because this left hand side is 0, when you cross multiply, you'll remain with 0. This, if you do a cross multiplication, guys, this is just going to be 0. So you only remain with 0 is equals to 2 minus k. Therefore, a is equals to 2. So we don't have to know p from here, because we know when you multiply p by 0, you'll just get 0. So that's why I don't worry much about that for now. So from here, we have k. So now we need to find p. So p, remember, comes from here. X minus p. X minus p. See that? So the formula for calculating p is x minus p equals to 0. This is the formula for calculating p. There it is from the standard formula. But even here it is. So you just take this, equate it to 0. And x is going to be the asymptote. The value of the asymptote, the x value of the asymptote. So what is the x value of the asymptote there? Remember, this is for p. So for p, we use the asymptotes because p represents a point of asymptote, right? So the x value of the asymptote here is 1. Let's say 1 minus p equals to 0. Therefore, p is equals to 1. I hope you saw that, guys. Or you can just say, from here, we know that this value represents p, right? from our formula, remember our formula, x minus the value of p, and we already know that is 1. X minus 1 is equals to 0. So x equals to 1, that point. And this line is the asymptote is p. So x equals to p equals to 1. Same thing. So I'm just proving. So this is the formula there. So now we have p, we have k. You can write the formula now, this formula with the values p and k substituted. Okay, so with the substitution, I'll say y equals to x minus k is 2, and x equals to, sorry, x minus p is 1. So the formula is x minus p, and p is positive 1. If p was negative 1, I was going to write it as a negative. If this was negative, I was going to write it with its own negative, bracket like. Hope you understand what I'm doing. Okay? 2, 1. There we go. So we have this. So from here, this is what you need to do. X minus 1, we know this is p. So from the formula of the hyperbola, we know the denominator is satisfied, x minus p. So we already have x minus 1. So we know this part will not change. It's fine. This part will remain as it is on the other side. So whatever we do, we're not going to change that because it already represents this part of the standard formula. We are not going to change that. So what you need to do from here, let me use a different color. We need to write the numerator, the top part, in a way that we have x minus 1. We have part of the numerator that is similar to the denominator. So y is equals to x minus 1, the denominator. So how can we make sure that we have x minus 1 on the top part, So this is what you do. You start by writing that x minus 1, and you close the bracket. X minus 1, close the bracket. So then from this has to be the same as that by simplification. So x minus 1 is not the same as x minus 2. So we need to work it out so that it is the same as x minus 2. So now we have x minus 1, which is similar to the denominator, but it is minus 1 instead of minus 2. So how can we make sure that it is still the same minus 2 here? So from minus 1 to minus 2 is going to be minus 1. So meaning if you were to solve this part, you have x minus 1 minus 1. Minus 1 minus 2 will minus 1 minus 1 will give you what? Minus 2. So x minus 2 is the same as this part. And we also have x minus 1, which is the same as the denominator. So here you fight to make sure that you have this term on the top part, but you do not change the total value of the top part to make sure that it is still the same value. This is still negative 2, just like there. And we also have the denominator represented as a on the. So once you have it like this, guys, we separate the terms. Remember guys, when you have 1 over x plus 2 over x if you write this with the use your lowest common factors single fraction, this will just be x over, sorry, it's gonna be 1 plus 2 all over x plus x and x, so that is going to be 3 over x. So now we are coming from here, we are separating them, we are moving from here going here, separating them. So y equals to x minus 1 all over x minus 1, and there's a negative there, then it's going to be 1 over x minus 1. So I separated this, the numerator there, separated this fraction into two parts like that. If I take it back, the denominator is the same, I'll just be taking it back like that. It's going to be the same thing. So once you have it like this, we can see that these are the same, they cancel each other, and you have that part. So basically you have y is equals to, this is going to be 1. So this whole term cancels this term, positive 1 minus 1 over x minus 1. So we can see this is in the standard form, but this is q, so q has to come this side, right? So I'll write it, write this side. I'll say y is equals to minus 1 x over, so minus 1 over x minus 1. This negative x, you can put it here or you can put it here, is the same thing. This, and this one is positive. See, positive here. There's no negative. So now I'm moving it to the side, positive 1. So now I have it in the standard form, because this is the same as y equals to a x minus 1 plus, sorry, plus p plus q. So you can see this is this. So we wrote it in the standard form. This is p, this is q, this is a. So that is what we did there. That is what we did. We moved from here to here using the x point of the asymptote there, the p, the x value of the asymptote, and one coordinate on the graph, to solve for k, preferably where y is 0, so that if y is 0, this whole part becomes 0. But even if it's not y equals to 0, you can still solve for k if you know the value of p. No p, you just substitute the coordinate and you substitute p, and then you'll only solve for k, be the only unknown. So once you have p and k, substitute them on the equation, and from here just simplify and then write it in the standard form. Remember, negative 1 still gives us negative 2. So you just change the format, but it's still the same value, because we want to have the value, that the same term that is on the denominator, we want to have it on the numerator. That is why we broke this, but it's still the same. Edit. Then we separate the terms, and this will cancel. We have that. So I took this one, this side, so that it represented nicely here, Q. That is it, guys.